The promise of the smart home was a frictionless, automated life. Instead, households today are a fragmented web of isolated gadgets that rarely communicate. This friction is built into the hardware. To make a smart speaker or a connected fridge function, manufacturers must pack tiny, redundant processors into every individual piece of equipment. This diagram shows the hidden cost of that design. Because these small processors cannot handle complex tasks, they must constantly export personal habits, schedules, and camera feeds to distant corporate servers for basic processing. By relying entirely on external processing, the modern household functions as a data extraction node for remote platforms, steadily moving private life into the cloud. Solving this requires a change to the physical network, not just the brand of devices we buy. We can consolidate that processing power into a single home core, a server tucked away in a closet that powers the entire household. Moving the hardware from a distant data center back into the home shifts ownership and control of the family's digital life back to the people living there. In this new layout, the internal network points inward, meaning every display, speaker, and camera connects directly to the central core rather than defaulting to the outside internet. Since the core does the heavy lifting, the screens and tablets in each room can be simple, thin clients, inexpensive interfaces that require no heavy onboard processors. Transitions are seamless. A child starts schoolwork on a kitchen tablet and instantly resumes in the bedroom. A parent runs high-demand software on a lightweight office terminal. If external internet drops, this resilient internal network stays active, managing media, security, and files without interruption. This architecture consolidates the household into a single coordinated system, allowing every room to draw from one high-performance resource. This central server also hosts its own localized artificial intelligence, providing a private brain for the entire household ecosystem. The AI handles the practical mechanics of the home, organizing schedules, tracking pantry inventory, and summarizing calendars, acting as a quiet tool rather than a constant observer. This diagram illustrates the privacy shield. Because AI is locally hosted, sensitive inputs, conversations, camera feeds, and habits remain within the physical perimeter of the house. The family can choose to query the broader internet, but external connections are an optional tool, not a mandatory requirement. Running AI on a local core is the only way to ensure a home remains private while becoming technologically intelligent. This model also changes how we maintain our technology over the long term. Currently, we treat smart devices like disposable goods, replacing them when they become obsolete. We would never accept that kind of waste from our plumbing or electrical systems. This chart compares those two life cycles. Instead of replacing every device in the house, a family can simply upgrade the central server, while the simple terminal screens remain in use for decades as stable infrastructure. This shifts computers from disposable gadgets into permanent, maintainable household utilities. The benefits of this architectural shift scale far beyond the single home and expand outward into the surrounding community. Schools can host private tutoring systems, libraries can offer shared compute resources, and small businesses can run automation without surrendering their operational data to outside platforms. This is digital sovereignty, a future where communities build resilient, local capacity instead of relying on extractive platforms. A positive future must be built intentionally. It requires technology that supports human independence rather than corporate observation. One home, one core, every room connected, every family in control.